Okay, we're almost done. Yay. So we have to look at the add method, add a node containing the value at the given index. So, and then at the end, I'm going to figure out this check index and what we want to do with it. For the add, again, we always want to think about, okay, I have my list, pretend like the 8's back in there, 8, 6, and 9. If I want to add something to the front, so I'm adding at index 0, a node containing a 5. So we need to think about, that's changing the front. So whenever we're going to change the front, remember front is a field in our class. So it actually has to change. You can't do this without changing front. So what we would do is we can't just change front right off the bat because then we would lose what front is pointing to. So we create a temporary node, and that temp is going to point to a node containing 5. We want that node to then point to what front was pointing at. So temp dot next. Well, we can actually create temp to do this, but temp dot next would need to equal front dot next. And then we would want then front to equal temp. So then front would go from there and point to here. Oh, sorry, front would go from here and then come down to there. Oops, I messed that. I messed those links up because I didn't realize I had already drawn it with the 5 in it. So go back for a second. This 5 needs to point. So remember, we have this list up here at the beginning. So the 5 here needs to point at the 8, which is currently the front. So temp.next does not equal front.next. It equals front, and then front equals temp. What about if there's nothing in our list to begin with? And that's the case, if front is null to begin with, what's going to happen? So it's a little more careful. If front is null, then would this still work? Temp.next would be equal null and front would equal temp. That would still work. So that's going to work regardless of whether there's anything in our list or not. Let's go over and code that. So we're going to put this add below the other add. Public void add integer index, integer value. Adds node. Well, I can just say adds the given value at the given index. And throws index out of bounds. Exception as needed. So when is it going to throw an index out of bounds? If the index certainly is less than 0, or, so in this case, can that index equal the size? If you go back to our list here for a second, here my size is 3, and if I wanted to add it at index 3, that would mean I'd want this 9 to point to the 5. And so it would be okay to add at that index. It'd just be adding it to the end. We have a method that does that. It's this one. So if index is less than 0, or index is strictly greater than size. So this is why I was nervous about doing an index out of bounds exception, because they're not all quite the same. Then we're going to throw a new index out of bounds exception. And that's done. Okay, and then sort of, I can think of, well, do I want two special cases? I'm not sure, but we know there's a special case at the front. So if index is 0, meaning we want to add to the front, we want to create, oh, we need to create that temporary guy anyway. So let's do that regardless. It's a integer linked node. Temp equals new integer link node, and I can just put the 5 in, let's see, the value in there. That'll create a temporary link node with a 5 in it. If index is equal to 0, we want temp.next to take on the value of front. And we want front to take on the value of temp. And we want to make sure that works. So, that's enough to check that we can add something at the top of our list. So let's go to our client. And we're going to call, so we remove the thing at 0. And now I'm going to add something back in at 0. List1.add 0, let's go -18 this time. And let's copy that print statement. And we'll check add at 0. Okay, and that put -18 in there. So we're good to go. I guess I was adding 5, so let's do that as well. Just copy that same line of code. 0, 5. What happens if we do it twice? Run it. Oh, I didn't add it in. It doesn't work. List1.add 0, 5. Run it again. And there's a 5, -18, 6, and 9. So it's exactly like this, except instead of having the 8, it's a -18. Okay, we'll go back to our link and integer list. We're in add. We took care of the special case. I now want to use this node at, and I want to think about, so let's suppose I want trying to add, let's go with this list on down here on the bottom. This is kind of the list we have. This would be a -18. And this is index, let's see, 0, 1, 2, 3. Suppose we're trying to add at index 2. So I want to add at index 2 a 13. So right in here, I want to put a 13. Okay, so, that's the pointer that needs to point at 13. If I used node at 2, that would return that pointer, but then that would be temp, and temp would point there. And if I change temp to point at 13, I then don't change this link. So similar to the remove, I actually need this pointer to come back from node at. So if I call node at 1, that would be this guy. And then we call that temp. So now temp is there, and then I want temp.next to point it up to 13, but before I move that, I need the 13 to grab temp.next.next, which is over there. So let's see so this guy on the right has to happen first. So let's see, temp is here. The yellow is temp.next. That's temp.next.next. So we need temp.next.next to equal, oh dear, temp is this guy. Temp.next would be that. Oh no. Yeah, no, I think we actually want this to point to here. Okay. Yeah. It's got to go in the middle there. So, let's see. So temp.next is that. Dot next would be this one. We want temp.next to equal temp.next. My pen's not going to work here. That's awesome on my eraser. So that's orange is temp. Temp.next is over here. I want it to equal orange.next, which is temp.next. Okay. And then we would want temp.next to equal the new node. So I guess I don't have enough names here. We need this new node that we're adding. And we need to give it a name. So let's call it new node. So new node is going to point to the 13. Okay. So then new node dot next, we want that to equal temp dot next. That takes care of that. That takes care of this. New node dot next equals temp dot next. We want the 13 to point at the 6, and then we want temp dot next to point at new node. So then temp dot next is going to equal new node. Yellow, that guy first, then that guy. Okay, it's a little tricky. Let's try it. It has to be done on paper. There's no way you can figure it. I can't figure it out without. You could see me going back and forth there a little bit. So we'll come back over here. We are in add. We've got this guy called temp. So I actually don't want to call this temp. I want to call this new node. And then new node dot next equals front, and front equals new node here. Okay. Because I want to call integer link node temp, and I want that to equal node at. And again, I don't want it to point at the index 2 that we're trying to add at. I want it to point at the index before that. So it's going to be at index -1. Then I want new node dot next. I guess this needs to be an else. If we're not looking at the front, that's where all this code goes. New node dot next is equal to temp dot next. And we could think about this, does that always exist? It should, because we know we're not starting at the beginning, so we're not pointing at 0. So then, does it always exist? What if our list is empty? Let's not worry about it just yet. If our list is empty, then this wouldn't be true unless, yeah, so somehow if our list is empty, that's going to crash us anyways. Or it's going to do it here. It's going to take care of it. Okay, so it's going to work because this index has to be bigger than or equal to 1. When you take away 1, it's at least 0. New node dot next equals temp dot next, and then temp equals new node. That should do it. Temp temp dot next. is where we want that to go, equals new node. That's confusing. Let's go through that again real quickly. We create a temporary pointer. That's this orange pointer that points before the index we want to add the thing at. We take the new node and we make sure it's pointing at whatever that thing, that next value is. So new node dot next equals temp dot next, and then we want to change temp dot next to point at new node. Perfect. And now I gotta check it. So go back to our client. And we just need to add, let's see, list one, something at index one. Let's add, oh, we're gonna add the index to a 13. And then we'll print our list. It's to a 13. Run it. 0, 1, 2, it went in there, 6 and 9. And then I should add something at the end of my list. So that would be at index 0, 1, 2, 3, 4. So let's try to add, I'll tell you both these lines of code. I'm going to add 0, 1, 2, 3, 4 at 5. Let's add a 99. Add 5, 99, run it. So we got index out of bounds. Okay, let's try to add 499, see what happens. We still got index out of bounds. Oh, we didn't increase our size. In this method, we just added stuff. We need to increase our size. So if I had tried to add it anywhere else, the next thing would have kept crashing because I didn't increase my size. So here I added the 99 at 5. Let's check it. Let's check it back at on the last position. I thought I did that correctly, but let's see. Yeah, it worked. So then the last thing to check would be, can I add it at index -1? It should crash. Yep, it crashes. Can I add it at index 10? It should crash. It does. Looks like everything else is working. I'm going to go back and leave it at 5. Go back to our code, link integer list. I know, I'm tired. The videos are a lot to do. So anyways, here we go. We got, really there's one, so there's a little bit of repetitive code, and that's like right here. This index greater than or equal to size. This is a different checking thing for index. So I don't really need to worry about it. I can leave it in there. I could leave them all, but I'm just going to do one more private method called checkIndex. And I'll put it below this linked integer node. I'll just call it private. Void checkIndex integer index. This is going to ensures the index is ensures that index 0 is less than or equal to the index, which is less than the size. And otherwise, else throws index out of bounds exception. And I'm only doing this method because this code occurs twice. So I'm just going to copy it out of there. And I'll paste it in here. And then instead of having this code, you can call the method checkIndex, sending that index in. And it's there in node at, and it's also up, I think, in get. Let's see, no, not in get, it's somewhere else. Here it is in remove. Same between 0 and thing, so I can just say check index here. And it might be one other place. Let's see. So this one is different because it's a greater than size. So I can't use that code. I could if I didn't have this less than 0, if it was said less than 1, but because of the 2 checks, I can't use it there. I don't need it there. It's fine. And then I think it's done. So I just did the add at a place. Where is that? I'll try to leave it on that so you can. Sorry, there it is. No, yeah, there it is. So you can pause if you need to, and I will post this code along with the videos online.